Hello everyone. First order ordinary differential equation can be solved using several methods. The first one is a separation of variable. Second is a linear differential equation. The third one is the exact equation, and the fourth one is the power series method. For the first one, separation of variables. Variable x and y are separable so that the x appears only on the right and y appears only on the left, and both sides of the equation can be integrated. Such a differential equation is called a separable differential equation. However, not every first-order ordinary differential equation can be written in separable form and cannot be solved by the method of separation of variables. However, some of the non-separable form ordinary differential equation can be reduced to the separable form by introduction of a new unknown function. Therefore, in this session, we will learn two ways of changing the non-separable form differential equation to separable form differential equation, namely reduction to separable form. In this session, you will also learn the homogeneous equation and non-homogeneous equation for the reduction to separation form. For the homogeneous equation, if the differential equation is a homogeneous equation, dy over dx is equal to fxy, and if x is replaced with the lambda x and y is replaced with the lambda y, also equal to the fxy, and the lambda here is a real number, the differential equation is called homogeneous equation with n degrees. This is the procedure for the step in solving the homogeneous equation. First of all, make sure that the differential equation is a homogeneous equation. Then substitute the y equal to xv. Okay, and dy over dx equal to the x dv over dx plus v in the differential equation. But how do we get this equation? Okay, for the substitution of y equal to the xv, since the v is in term of x, so we differentiate the y equal to the xv by using the product rules. So dy over dx is equal to uv prime plus vu prime. Therefore, we get the x dv over dx plus v only. And then the next step is to solve the equation by the method of separation of variables. And then step 4, substitute back the v equal to y over x. And then if there's any initial condition, we can substitute and get the value. Now let's look at the example. Solve the first order differential equation xy squared dy over dx equal to the x power 3 plus y power 3. In order to solve this equation, we rearrange the equation in the form of dy over dx equal to the x power 3 plus y power 3 divided by x y power of 2. Okay, so this is the question. So we rearrange into dy over dx. So we move this one to the right hand side. And the fxy is equal to the x power 3 plus y power 3 divided by xy squared. And then we substitute the x to lambda x and substitute y to lambda y. And therefore we obtain the lambda x power 3 plus lambda y power of 3 divided by lambda x lambda y squared. So we obtain, and then we take out the lambda power of 3. So we still obtain the x power of 3 plus y power of 3 divided by x power of 3. So lambda multiply with lambda squared, so we get lambda power of 3. So we factor out, we obtain xy squared. So this is equal to fxy. So this is the differential equation is a homogeneous equation. So what is the degree? The degree lambda is lambda equal to 3. Okay? And then step 2, we use the transformation of y equal to xv and the product rules. So dy over dx is equal to the x dv over dx plus v. Okay, and therefore x dv over dx plus v equal to dy over dx, right? So this dy over dx we substitute with this value. Okay, so we get x power 3 plus y power 3 divided by xy squared. And as you know, y is equal to the xv, so we can substitute in the y. Okay, so I obtain x dv over dx equal to, so this one I obtain x power of 3, then I can factor out, I can get 1 plus v power of 3 divided by x power of 3. Okay, so x times x squared, we get x power of 3, and then multiply with v squared. So we move the v to the right hand side, so it's minus v. Okay, this one we can cancel out. Okay, we left the denominator is v squared, so therefore we also time with the v squared. So we want to make the denominator is the same denominator. And therefore I obtain 1 plus v power of 3 minus v power of 3 divided by v squared. So this one can cancel out, and I get 1 over v squared. Okay, so x dv dx equal to 1 over d squared. So I move the v squared to the left hand side. So I obtain v squared dv, and I move the x to the right hand side. Okay. So I get 1 over x dx. Now I can, this means that I separate the x and the v. So left hand side is the v, right hand side is the x. So step 3 is I can solve using the method of separation of variables. Separation of variables methods means that you separate the v to the left hand side, you separate the x to the right hand side, and then I integrate. So I integrate both sides, and I obtain the v power of 3 divided by 3 plus c1. Okay, integrate 1 over x, I obtain lambda ln x plus c2. And then step number 4 is I substitute back the v equal to y over x. So I obtain the y over x power of 3. This one is 3x power of 3 equal to ln x plus c, in which the c is equal to the c2 minus c1. Alright. Next, I would like to share with you another example. Solve the following first order differential equation. X dy over dx equal to the y plus x cos square y over x. Again, in this question, we can, first of all, we can rearrange the equation. So dy over dx, we keep it at the left hand side, and we move the x to the right hand side. So y plus x cos square y over x divided by x. And then fxy, okay, is y plus cos square y over x divided by x. So this we assume the dy over dx is this one, and then we substitute the x to lambda x and substitute the y to lambda y, and what we obtain. So lambda y plus lambda x cos square lambda y divided by lambda x. So divide by lambda x. And then we factor out, okay, we factor out the lambda, and then we obtain y plus x cos square. This one we can cancel out, we obtain y over x. And this one we divide by lambda x. Okay, so this lambda we can cancel out, actually is the same as fxy. So therefore we can say that this differential equation is a homogeneous equation with the degree equal to 1 because lambda power of 1. Since this is a homogeneous equation, we can use the transformation of y equal to xv. So as you know, y equal to xv, then dy over dx is equal to the x dv over dx plus v. So this is from the product rules of y equal to the xv. So x dv over dx, we take this part, plus y equal to, okay, dy over dx, we can use this equation. So equal to y plus x cos square y over x divided by x. So we substitute the y with xv. Okay. And therefore, we can cancel out this. We factor out first. Okay. We factor out first. There's an x and x, right? So we can cancel. So we factor out v plus cos square. And then this one also can cancel out. So we get v only. And then this is x. So we can actually cancel out. So this is the equal to v plus cos square v. Okay. And then left hand side is a x dv over dx, and then we move this v to the right hand side, so it's a minus v. So here we have the v, and then here also have v, and then this is x. So we move the v, okay, to the left hand side, we move the x to the right hand side. Before this we can cancel out because this is v minus v, so this one we can cancel out. Okay, and then we left cos square v only. So move to the left hand side. So we get 1 over cos square v dv equal to 1 over x dx. And now we can solve using the method of separation of variables. So integrate both parts. And then integrate 1 over cos square v, we obtain the 1 over cos square, we obtain sec square v dv. Okay, integrate sec square, we obtain the tangent v plus c1. Integrate 1 over x, we obtain ln x plus c2. Next, we can substitute back the v equal to y over x. So we get tangent y over x equal to ln x plus c, in which c is equal to c2 minus c1. Okay, that's all for this question, and we move to the second question. Second question is 2x dy over dx minus 2y equal to x squared plus y squared square root. Again, first of all, we rearrange the equation into dy over dx equal to the x squared plus y squared square root plus 2y divided by 2x. So we assume the dy over dx is f xy, and then we obtain the same things. And then we substitute the x with lambda x, substitute y with lambda y. So I obtain lambda y square plus 2 lambda y divided by 2 lambda x. So we factor out the lambda, we get the x square plus y square, because inside is a lambda square square root, so we can get the lambda here. So plus with 2y divided by lambda 2x. So here actually if we cancel out and we obtain the same value. So this is equal to fxy. Therefore the differential equation again is a homogeneous equation with the degree of 1. And then step 2, we using the transformation of y equal to xv. So dy over dx is equal to the x dv over dx plus v. So x dv over dx plus v equal to, we use this equation. So x squared plus y squared square root plus 2y divided by 2x. So we obtain the x squared plus y. Okay, y we substitute with the xv. So xv squared plus 2xv divided by 2x. Okay, so we can factor out the x. So we get x 1 plus v squared plus 2xv divided by 2x. So from here we can cancel out the x here, and then we left 1 plus v squared square root plus 2 divided by 2. So this part is the x dv over dx, and then we have the v here, we can move to the right hand side, so it's a minus v. So we can solve this one. 1 plus v squared square root. So we multiply the v here with 2, so we have the 2v. So plus 2v minus 2v, we can cancel out. Okay, so we just left nothing, cancel out already. So it's divided by 2 only. So this part we also can remove the v to the left hand side and x to the right hand side. So we separate it. Therefore we obtain 2 over square root of 1 plus v squared dv equal to 1 over x dx. And then the third step is to use the separation of variables. Means we integrate both parts. And then we obtain integrate 1 over square root of 1 plus v squared. We obtain sinh inverse sinh v equal to ln x plus c. And then we substitute back the equation v equal to y over x. So we obtain 2 sinh inverse y over x equal to the ln x plus c. So all this is the homogeneous equation. Now let's look at another example. Solve the first order differential equation of x power 4 plus y power 4 dx minus x y power of 3 dy equals 0. So obviously this is a differential, this is the homogeneous differential equation. To do this, we rearrange the equation into dy over dx equal to the x power of 4 plus y power of 4 divided by x y power of 3. Okay, we bring this x squared, x power 4 plus y power 4 to the right hand side. Okay, so we obtain the dy over dx is equal to x power 4 plus y power 4 divided by x y power 3. And then we assume the fxy equal to x power 4 plus y power 4 divided by xy power 3. And then we substitute the x with lambda x and y with lambda y. And therefore we obtain lambda x power of 4 plus lambda y power of 4 divided by lambda x lambda y power of 3. So here we get the lambda power of 4, we factor out lambda power of 4, and then we left x power of 4 plus y power of 4 divided by this one, lambda, and multiply with lambda power of 3, you get lambda power of 4, and here we obtain x y power of 3. So this one is as if we can cancel out this lambda power of 4, we remain this part, which is same as the fxy. This means that it is a homogeneous equation, homogeneous differential equation with degree of equal to 4. So the step 2 is using the transformation of y equal to the vx, since this is a homogeneous equation. So we using the product rules, we obtain dy over dx equal to the x dv over dx plus v. So x dv over dx plus v equal to the x power 4 plus y power 4 divided by x y power 3. So this one we use the dy over dx value here. So we substitute the y equal to vx. So we have x power 4 plus v power of 4 divided by x v power of 3. So this is equal to x power of 4 plus x power of 4 v power of 4 divided by x power of 4 v power of 3. So actually we can cancel out the x power of 4 here. And then we left 1 plus v power of 4 divided by v power of 3. So x dy over dv over dx is equal to 1 plus v power of 4 divided by v power of 3 minus v. Okay, we bring the v to the right hand side, so minus v. And since the denominator is v power of 3, so we multiply with v power of 3. And then v power of 4 minus v power of 4 we can cancel out, and then we left 1 over v power of 3. So we can separate the v and x by move the v to the left hand side and x to the right hand side. So therefore v power of 3 dv is equal to 1 over x dx. And then we can use the separation of variable methods, which is in step 3. So integrate both parts. So integrate v power of 3 dv equal to integrate 1 over x dx. You integrate v power of 3, you get v power of 4 over 4. Integrate 1 over x, you get ln x plus c. And then step 4, we substitute back the value v equal to y over x. Therefore, we get y over x power of 4. And we move the 4 to the right hand side, and then we get 4 ln x plus c. And that's all for this question. for the homogeneous differential equation. Now I believe that you already understand the step or the procedure to solve the homogeneous differential equation using the reduction to separation form. Previous example that I show you is the homogeneous equation. What if the differential equation is not homogeneous? Okay, so normally we apply other transformation to reduce the ordinary differential equation to a separable form. A very common transformation is to let y equal to v divided by x. Okay, so for the homogeneous, we use y equal to the xv. Do you still remember? So this is the homogeneous equation. We use y equal to xv. For non-homogeneous equation, we use the transformation of v divided by x. Okay, now let's look at the example. Show that the general solution for the first order differential equation dy over dx is equal to negative y xy plus 1 divided by x multiplied with 2 plus xy is log 2 ln yx plus yx equal to ln x plus c. We need to prove that using this transformation. To solve this question, first of all, we must check whether the differential equation is homogeneous equation or not. So dy over dx is equal to negative y xy plus 1. So this is from question. And then we assume the dy over dx is fxy. And then we substitute the x with lambda x and substitute y with lambda y, which is equal to negative lambda x and negative lambda y. Lambda x multiplied with lambda y plus 1 divided by lambda x, 2 plus lambda x, lambda y. So can we factor out the lambda? We cannot factor out because of this one. Okay, we don't have the lambda here, so we cannot factor out. Here also cannot factor out. So this is not the same with the fxy. Therefore, we can say that the differential equation not a homogeneous equation. So what we have to do? As I told you just now, we use the transformation of y equal to v over x. So therefore v equal to y over y multiplied with x. Therefore we get dy over dx equal to x dv over dx minus v divided by x squared. Do you know how to obtain this one? Okay, as I told you just now, we can use the product rules because we assume that the v also is a term of the x. So therefore, we can assume that okay, y equal to v x minus 1. So we assume this is u, this is v. So dy over dx is equal to uv prime plus vu prime. So u is v here, and then v prime we obtain negative 1 x power of negative 2 plus v, we have the x power of negative 1, and then u prime is dv over dx. So here we can get this is negative 1 multiplied with v, so you get negative v divided by x squared plus dv over dx multiplied with x power minus 1, so it's 1 over x. Since this part we don't have the same denominator of x power of 2, so we multiply with the x power of 2. Okay, we multiply this one. So this is multiply, okay, multiply. So therefore we get negative v over x squared plus dv over dx. So this one we can cancel out 1, so we left x divided by x squared. So therefore we rearrange, we obtain dv over dx, x minus v over x squared. So this value is the same as this one. This is how we obtain the dy over dx. Okay? So after we know how we obtain this one, so we can substitute the dy over dx equal to the x dv over dx minus v divided by x squared. So this is equivalent to x dv over dx minus v divided by the x squared equal to the first one, okay, equal to the minus y. This minus y, xy plus 1 divided by x, 2 plus xy. I write it down here with minus y, xy plus 1 divided by x, 2 plus xy. So this is equal to negative x squared v over x, x v over x plus 1. We substitute the y equal to v over x. Okay, you have the x, 2 plus x, so y is v over x. And then we can cancel out. This one can cancel out, we left 1. This one also can cancel out. This one also can cancel out. And then we left minus v plus 1 divided by, okay, this one we also can cancel out. And we left 2 plus v here. And then this is equal to x dv over dx. And then we move the negative x to the right hand side, so we have plus v. Okay, so you have negative v squared minus v plus 2v plus v squared. Because this one is a numerator, we don't have the same denominator, so that's why this v value multiplied with 2 plus v, we obtain 2v plus v squared. So it's divided by 2 plus v. And now we move all the v to the left hand side and all the x to the right hand side. So we obtain 2 plus v divided by, okay, can we cancel out this one? Negative v plus 2v, so you have the positive 1v. And this one can cancel out. So you have 1v only. This is move the x to the right hand side, so you have 1 over x dx. And then we can solve using the method of separation of variable, which is in step 3. So we integrate both parts. So integrate 1 over v, we obtain ln v. 2 is a constant. Integrate 1 dv, you get v plus c1 equal to ln x plus c2. And then we can substitute back in the step 4, v equal to yx. So we have 2 ln yx plus yx equal to ln c plus c. C equal to c2 minus c1. So that's all for this question, how we solve the non-homogeneous equation. Alright, thank you for watching.